Right, so this next set of videos is dedicated to geoprocessing. This is where you're going to be doing several tasks where you're beginning to get your data ready for analysis and then allows you to actually analyze data. And when we think about our reasons for doing GIS, or our, excuse me, our 5 things that we need to do GIS. We need people, we need hardware, we need software, we need data, and then we need a reason to do it. And so that reason a lot of times winds up being to map something, to analyze it, and so geoprocessing allows us to perform that analysis. So what I've provided here in the Geoprocessing Resources PDF is several items from ArcGIS. There is a link here to the help, online help for ArcGIS, and I'll bring up that page here really quick. And what is geoprocessing? A basic description of it. It gives you a bunch of information and a couple of examples of different types of geoprocessing tasks that you can do. You can have a quick tour of geoprocessing, the toolbox, and we will start using Arc Toolbox. At this point, you'll be doing it in chapters 11 and 12 in the Green GTK book, where you're going to practice a lot of the things and then some of the things I'm going to demonstrate here as part of the video. So a lot of the geoprocessing tasks and tools that are available can be found within this ArcGIS Resource Center. So there is a link. This link right here links to that online page. So this resource document that I put together some time ago is just taken from a lot of the ArcGIS resources, and feel free to use it, take it with you, and refer to it periodically. All it is basically a listing of some of the more common geoprocessing tasks. I will demonstrate how to do a buffer. I will demonstrate how to do a clip. I will demonstrate how to do a dissolve, and then I'll show how to do one of the 3 main types of overlays that you do as part of geoprocessing. So there's always going to be some sort of an input, some sort of a process, and then some sort of an output that comes out of these geoprocessing tasks. And a lot of times this is mainly getting data ready for analysis, and then a lot of times these geoprocessing tools are meant to actually perform some sort of an analysis. For example, our overlays, we have 3 different main types of overlays, an intersect, a union. You can see the difference in the outputs depending on which one of these tools you use, and again, that's going to depend on that application or that reason you're doing your analysis or using GIS. And so I'll keep a context for the demo that I'm going to do here in just a few minutes. Just again, some commonly used tools. There is another type of overlay a little bit further down here called the identity. So those are the 3 main types: intersect, identity, and union. So an identity performs a slightly different overlay in terms of what you input through your 2 different features into your output feature class or your output shapefile. So again, just peruse this document, take a look at it. Some common ones, some tools that honestly I've never even used before, and you're going to find that in Arc Toolbox there is a plethora of tools that you could potentially use here. Some of the ones that we're going to be using here are going to be our proximity analysis. We'll be doing buffers, we'll be doing some overlay, and then we'll be doing a little bit of extract where we're going to be clipping some data. So you can see my data frames are named accordingly here, and we're just going to kind of work through each one of these and build to a basic analysis. So this is where, again, where we break into Arc Toolbox, doing some of these geoprocessing tasks. Again, in some cases to analyze data, in other cases to prepare data for analysis, and again within chapters 11 and 12 you'll be doing that. Another place where you can find a lot of the tools that we're going to be using, I'm going to go ahead and close out the toolbox here, is under the geoprocessing menu in ArcMap. So some of the more common ones that we use, and of course we're going to be doing buffers, clips, we'll be doing a dissolve, and then we'll be doing probably an intersect as part of my overlay video. So we don't even need to get into Arc Toolbox to pull up these different tools, but again, these are just put here because they're the more common ones. But again, you can launch Arc Toolbox to see all the different types of tools that are available to you. And so some of these get into much more advanced analytics that you can do with your GIS data. So for the purposes of this demonstration, and most of my demonstrations, I like to have some sort of context. So what I'm going to do is I'm going to dedicate this particular video to prepping data. So I'm going to do my dissolves and I'm going to do my clips here in this demo. I'll do a demo for buffer, and then I'll do a demo for overlay. And so those are going to be 3 different videos that you're going to see here. So I'm going to go ahead and start with a dissolve. One of the reasons that you would do a dissolve is simply to make larger aggregated polygons out of smaller polygons. Now I'm going to do a couple of different dissolves here. One case would be maybe, for example, these Maryland counties that I'm showing here in my map. They're the 23 counties in Baltimore City in the state of Maryland. If I open up the table on MD counties, open up attribute table, and I'm going to bring that over to my other screen so you guys can see that. I've grouped all of these counties into different regions. So maybe they're part of different planning, regional planning boards that each of those different counties is part of. So I can come in here and I can just symbolize those counties according to their regions, and I'll add all those values, and I'll say OK. And now I can see my Maryland counties according to the different planning regional planning boards that they may be part of. Now let's say I wanted to have just a shapefile of just those regional boundaries without having the actual county boundaries put in there. I could go ahead and do a dissolve, and what that's going to do is wherever the attribute for the particular field, in this case region, is the same, it will dissolve out the lines in between them. So what I'm going to do here is I'm going to go ahead and take my Maryland counties back to my original symbology. And again, I'm just kind of giving us some context here with the Maryland water and the Maryland counties. But if I wanted to do a dissolve, I could just come up to Geoprocessing here, and I'm going to say dissolve. And that's going to open up my dissolve window, which again I'll bring over to the screen here. And I'm going to tell it that I want to dissolve my Maryland counties. And it's going to ask me, what do I want to call it? In this case, I am going to write out a shapefile into my output folder. I have my Geoprocessing demo folder on my desktop, and so here's a lot of the data that we're working with within the context of this demo. So I'm just going to try to keep it a little neat and tidy here, just have an output folder, and I'm just going to call this MD regions.shape, and I'm going to go ahead and say save. Now I got to tell it which one of these fields I want to dissolve on, because if I didn't specify a field, it will dissolve out everything and I'll wind up with one big state polygon. So I'm just going to go ahead and click on region. Now if I wanted to run some statistics on some of the numeric fields for each of those counties, I do have the option to do that down here. One example might be for each of those counties I might have a total county population, and so I could come in here and select that field, and in this case I don't have that population field. But if I did have that population field, I could add that down here and then tell it that I wanted to do a sum of it. So for each of the regions it would give me a total for a total population based on the individual county populations. For the purposes of this demo, I'm not going to do that. I'm just going to basically do a geometry dissolve based on the region field. So I'm going to go ahead and run that. And you can see ArcGIS is kind of telling you, hey, I'm doing some work down here. I'm doing the dissolve. And once that's done, it's automatically going to add in that new shapefile called MD regions, and it will give you a little message, usually with a green checkbox, which is actually showing up on my other screen right now, that says the dissolve was completed, and a little green checkbox tells me that everything went just fine. So now what I can do is I can just symbolize that based again on that region field, add all values. And now I have a shapefile that was derived from the Maryland counties file, but now I have just a Maryland regions file. And again, this is just an example of maybe we're creating a shapefile of regional planning councils that each of the counties is part of. But the real context for my discussion here is going to be a water quality discussion. So this is more of an environmental application. So you can see the state of Maryland. I'm going to go ahead and zoom into the Baltimore County region here, and you can see Pretty Boy Reservoir, Lock Raven Reservoir, and Liberty Reservoir. These 3 reservoirs are drinking water reservoirs that serve the metropolitan Baltimore area. So our environmental application here may be we're concerned with water quality. So one of the things that I can do here is turn on my Maryland watersheds, and we can see how the state is divvied up into the different watersheds. So basically any water that falls within any one of these polygons is going to drain into these bodies of water, and ultimately all of this is going to drain into the Chesapeake Bay. So we're always concerned with the health of the bay, and so our actions on land, the types of land uses, our activities on land are obviously going to contribute to water quality. So if we're concerned with water water quality of our drinking water reservoirs, we may be interested in doing some sort of an analysis that looks at maybe underground storage tanks that are that could potentially pose a risk to the water quality, or trying to summarize the types of land use around our bodies of water to get an idea of where we might be getting most of our affected our areas that would mostly affect our water quality. So in this case, I've got my Maryland watersheds turned on. So I'm going to go ahead and click on this big polygon right here, and we can see that that's part of the Loch Raven Reservoir watershed. And so you can see that I also have the Maryland subwatersheds. Now the map does start to get a little bit more complex there with so many different layers turned on, but I'm just going to go ahead and zoom in a little bit tighter here. And so you can see here's the Loch Raven Reservoir. This thick almost black gray, dark gray outline represents the larger watershed, and then each of these smaller watersheds, I'm going to go ahead and switch this over to subwatersheds so I can query on those. I can click on each individual subwatershed and see the different individual units that make up the larger watershed. So in this case, I'm going to go ahead and turn on Maryland streams here, and you can see the individual streams that fall within each one of those watersheds, and of course all of those contribute water into Loch Raven Reservoir, which again is part of our drinking water supply for the Baltimore area. So I'm going to go ahead and remove Maryland streams because I'm actually going to use that further down here in the clips and in the buffer. You can see that my streams go outside of Maryland, so that's a little bit messy there. So we're going to go ahead and remove that, and I just wanted to use that to give you some context. And so we've simplified the map a little bit here. So another reason we might want to do a dissolve, as I mentioned, the regional planning councils for each of the counties is one reason we might want to do that. But another thing we could do, I'm going to go ahead and turn off my base data to again sort of simplify my view here. Maybe you've gotten watersheds from one source and subwatersheds from another, or maybe the quality of the data capture isn't all that great. So I've got a couple of discrepancies here. So maybe one of the reasons I would want to do a dissolve is so that I have some consistency between my larger polygon and the edges of any of my adjacent watersheds that fall within the larger watershed. So what I'm going to do here is maybe I'm just not interested in using this overall watershed boundary simply because I want these boundaries to what's called conflate. This is a conflation issue where these two layers don't match up. So what I'm going to do here is I'm actually going to scrap the Maryland watersheds layer. I'm going to remove that. And I'm basically going to select for only the ones that are Loch Raven Reservoir. So if I open up the table here, I have several attributes that tell me some information about the watersheds. But the one that I'm really interested in is MD8 name. That's the one that's going to tell me the hydrologic unit code for the watershed that I'm interested in. So I'm going to go ahead and do a query here. One of the skills that we learned earlier in the semester, and I'm going to query against Maryland subwatersheds. I'm going to come down to the 8-digit code name because all of these different watersheds are part of larger and smaller hydrologic units as they're known. So I'm going to go ahead and look for the watershed that is just part of Loch Raven Reservoir, which I think I just skipped. So there's Loch Raven Reservoir. So when I apply that query, it highlights just those polygons. And now one of the things I can do is I can write that out to its own shapefile, or I can actually come up here and come up to selection and go to create layer from selected features. And so what that does is that creates a new temporary layer. Now again, this is just temporary and in memory within this untitled MXD file that I've created. So now I've got only the subwatersheds that make up the larger Loch Raven watershed, and again Loch Raven is going to be the watershed that falls down here. So if I turn that off, this is where all the water that falls within these green polygons is going to be draining ultimately and going into our water system. So I do have the choice, if I come back to my Maryland subwatersheds layer, to actually right click, go down to data and export data, and into my output folder I'm going to create a new shapefile called Loch Raven subsheds. So those are the subwatersheds that make up the larger Loch Raven watershed. So when I say OK, I'm going to add that. And again, it does the same thing. So the difference here is that this Maryland subshed selection, again, is only temporarily in memory, but I can do geoprocessing on that layer. If I wanted to have an isolated shapefile, I could export it, and then that is represented by my tan layer here. So in either case, I'm going to go ahead and just remove, for the purposes of clarification, just remove that layer, and now I'm just down to the Lochraven subsheds. And so if I open up that attribute table, I can see all the different attributes, but the one common one is going to be Lochraven Reservoir. So when I go ahead and run my geoprocessing tool here, my dissolve, I want to dissolve Lochraven subsheds, and I'm going to call this just the Lochraven watershed. That's the overall watershed. And then the dissolve item that I want to use in this case is going to be MDE 8 name. And I'm going to say OK. So again, ArcGIS tells me that it's doing something. It's completed the dissolve, and now I have not only the larger watershed boundary, but then the smaller sub-watershed boundaries. And since this larger polygon was dissolved out of my smaller polygons, they match perfectly right along the edge there. So again, another reason why we would maybe do some data preparation and do some planning ahead of time before we actually try to do our analysis. So this is basically going to define my area of interest as we go into our buffer and our overlay analysis later on. So what I'm going to do in the next segment here is to come down to the clip demo, and I'm going to activate that data frame. And you can see again I have the same base data here, Maryland counties and Maryland water, as I had up here with my dissolve. I'm interested in these two particular subwatersheds, so watersheds and subwatershed layers. So I'm going to drag them down there, and I'm just going to go ahead and collapse my dissolve data frame. And now I'm working only within my clips data frame. Again, just to kind of keep things more neat and tidy. And so let's say for argument's sake, I'm interested only in what's going on within this watershed, because again, this is where Lochraven is located. So what I'm going to do here is I'm going to turn on Maryland underground storage tanks, and I'm going to turn on Maryland streams, and I'm going to go ahead and zoom out to the extent here, and you can kind of see what I'm getting at. I've got a large data set for the entire state. I've got streams for the entire state, and I've got underground storage tanks for the entire state. And so I'm only interested in what's going on in this particular area here, and of course within the subwatersheds, which we'll then probably use later to look at putting that into my map to provide some context. But for now, I'm only interested in having the underground storage tanks, which again could pose a water quality hazard, and also looking at the different streams that those underground storage tanks could pose a hazard to. I only want them for that smaller area, that Lochraven watershed. And so that's going to just make processing a lot faster. It's a smaller data set to deal with, and I don't need all of this other data that falls outside of my watershed. I just want to focus in here, so I would use a clip. Again, we have the option here to use our extract, our analysis toolbox, go to extract, and you would use the clip tool. But again, under the geoprocessing menu, you've got the clip tool, and it is basically doing the same thing as the tool within the toolbox. So in this case, I want to put in my input features is basically what I'm clipping. So I want to clip Maryland streams. And what I call the cookie cutter is the clip features. So the Lochraven watershed is what I want to clip. So in this case, I'm going to go to my output folder, and I'm clipping the streams. So I'm going to call these Lochraven streams. I'm going to say save. I'm going to say OK. And again, ArcGIS is going to tell me it's doing something. And now I have a whole new layer. Instead of using my Maryland streams, my Maryland underground storage tanks, I'll turn those off for just a second. And now I've got a data set that is clipped down basically only to the area that I'm interested in for my area of analysis. And again, I can go ahead and do the same thing. I don't need all of these underground storage tanks that fall outside of the reservoir watershed. I'm going to go ahead and make a hollow fill there so I can see my Lochraven body of water, the streams that lead into it. Streams are blue, so I can just go ahead and change those to blue really quick. And now I'm going to target these underground storage tanks that are only within the Loch Raven Reservoir. So again, I'm going to come over here to geoprocessing. I'm going to say clip. I want to clip my underground storage tanks. I want to clip them with, again, my watershed, and I'm going to call these, I guess I'll just call these Loch Raven UST for underground storage tank. UST, underground storage is what I'm going to call that. And I'm going to say OK. That's going to run very quickly because that's just the point layer that's being clipped. I can now turn off my Maryland underground storage tanks, and I'll turn off my base layer, and now I have several data sets that I'm ready to do some analysis on. Again, the point to using a lot of these geoprocessing tools is not only to do the analysis, but doing the preparation for analysis as well. So what I'm going to do is I'm going to jump into the buffer data frame in the next demo, and we're going to go ahead and buffer these streams and define a critical area that we want to find out which of these underground storage tanks falls within, so that we can sort of do a report and figure out where we need to target our inspections. Again, some context for the analysis, and so moving on now to the next video for buffers.